Hello students, this is the Bodhee Prep QA topic tests that you are looking at. So basically the idea of the topic test is once you've prepared a topic, you take the test to understand whether that topic is actually exam ready. You watch this video after you've taken the test and you get an idea of the kind of attempt that you should have done and a broad analysis of the test. There are more than 200 such topic tests available on the app. So you can download the app from the link that is given in the description below and make use of these tests. This video specifically talks about test number 3 on the topic factorial, cyclicity, and base system. The overall analysis for this test is that it was a moderate level of difficulty test. About 6 to 7 questions would be a good attempt, and the time to attempt this paper would be, or the test would be about 18 to 21 minutes. If you look at the questions one by one, the first question says, for a positive integer n, let Pn denote the product of the digits and Sn denote the sum of the digits, the number of integers between 0 and 1000. So we are talking about 2-digit, 11, 12, 13, 14 up till 99, and 3-digit numbers. Suppose the 2-digit numbers of the form AB. So according to the question, Pn is the product of digits. So A into B plus Sn is the sum of digits. A plus B is the number itself. The value of the number will be 10A plus B, 2-digit number. So AB plus AB is equal to 9A, 10 minus A, B and B cancelled. So basically AB is equal to 9A, A and A cancelled because A cannot be 0, it is a 2-digit number, B is equal to 9. So once you put B is equal to 9, A can take any value. So A could be anything from 1 to 99, 1 to 9 basically. So the numbers could be 19, 29, 39, 49, 59, 69, 79, 89, 99. For example, 29. 29, 2 into 9 is 18. 18 plus 2 plus 9 is 11. 11 plus 18 is 29. So these are the 9 numbers that will satisfy, 2-digit numbers that will satisfy the value, the condition. If you look at the 3-digit number of the form ABC, the product of digits will be A into B into C, plus the sum of digits will be A plus B plus C, and this is nothing but the number which is 100A plus 10B plus C. C and C cancelled, ABC, the product will be 99A plus C and C cancelled, 9B. Now, if we put the value or if we try to get a solution for this equation where ABC the product is equal to 99A plus 9B plus C. I'm starting by putting the value. Now, the maximum value that ABC can take, A into B into C can take, when all three ABC are 999. This is 729. That is the maximum that can happen. And therefore, the maximum value that A can take will be 729 divided by 99 will give us somewhere around 7. So the maximum value that A can take is 7. Let us put the values of A and check. If A is equal to 1, we get B into C is equal to 99 plus 9B. B into C maximum can be 81, cannot reach 99. If we put A is equal to 2, we get 2 into B into C is equal to 198 plus 9B. Again, B into C can be 9 9s are 81, 2s are 162, cannot reach 198. And that will be the case for all the values. So here there will be no solution possible. So how many such numbers are possible? Option D, 9 becomes the answer. In terms of level of difficulty, I'd say a moderate to difficult level of questions may not be conceptually, but the solution might be challenging, and therefore 2.5 to 3 minutes to solve the question. How many 2-digit numbers with a non-zero digit in the units place? 2-digit number, non-zero are there which are more than thrice the number formed by interchanging the position of the digit. So if our number is AB, it is more than 3 times the number formed by interchanging the digits, that is 3 into BA. Now the value of this number will be 10A plus B. This is more than thrice of 10B plus A. This gives us 10A plus B is greater than 30B plus 3A. 10 minus 3, 7A is greater than 29B. B is a non-zero number. Therefore, how many two? If we take B as 1, this is 29 right hand side. So A can be 5, 6, 7, 8 or 9, 35, 42, 49, 56, 63 greater than 29. If we take B as 2, 29 twos are 58. For 7A to be greater than 58, A has to be 9. If we take B as 3, 29 threes are 87. 29 threes are 87. 7 into 12 will be 84. So A cannot take a two-digit number value. And therefore, these are the solutions possible. A could be 1. The number could be 51, 61, 71, 81, 91 or 92. 1, 2, 3, 4, 5, 6 options are possible. In terms of level of difficulty, I'd say a moderate level of difficulty question based on decimal system. Uh, Finding the solutions is the challenge here. Otherwise, conceptually not very difficult. The digits of a three-digit number in base 4 get reversed when it is converted to base 3. How many such numbers exist? The digits of a three-digit number in base 4 get reversed. Suppose the digits are A, B, and C. So what it says is ABC in base 4 is CBA in base 3. So the decimal value of this will be 1, 4 is to power 0, 4 is to power 1, 4 is to power 2. 16A plus 4B plus C converting into decimal is equal to 9C plus 3B plus A. This gives us 15A plus B is equal to 8C. Also, A, B, C have to be values which are less than 3 because these are the digits in base 3. In base 3, the only digits possible are 0, 1 and 2. Now, A also cannot be 0, then it will not be a three-digit number, C cannot be 0. If we put A as 1, we get 15 plus B is equal to 8C. C can be 2 or has to be 2, in which case B will be 1. So 15 plus 1 becomes 16. So if I'm looking for solutions for ABC, when A is 1, C has to be 2 because 8 ones are 15 plus B cannot be 8. It has to be more than 15. So A has to be C has to be 2, which gives me B as 1. Next, if we put 15 as A as 2, 30 plus B is equal to 8C. Now the maximum value that C could have taken was 2. So the maximum that this can be 16, it cannot reach 30. So there is no solution possible for AS2 and there are no other values that A can take. The only value possible for ABC is 1, 1, 2. So how many such numbers exist? 1. Again, because the bases are small, base 3 leaves only 3 digits that can be used. Therefore, I'm saying the attempt time will not be very high because the number of solutions to be found is limited. In terms of concept, I'd say moderate level of difficulty concept. In a three-digit number, the unit digit is twice the tens digit. Three-digit number, unit is twice the tens digit and hundreds, and the tens is twice the hundred. So if this is x, this is 2x, this is 4x. Possibilities could be 1, 2, 4, 2, 4, 8, 3, 6, 12 is not possible. So these are the only two numbers possible. The same number is written as 1xy, 1yx in base 8 and 9. Now 248 converted to base 8 or 9 will not have the first digit as 1. This is in the decimal system. When we convert it into base 8, it will be more than the number in base 8. So 248 is not the number. We are talking about 124 in base 10. 124 in base 10 converted to base 8 will be, the powers are 1, 8 and 64. 64 ones are 64, we are left with 60. 8 sevens are 56, 1 fours are 4. So in base 8, this will be 174 in base 8. If I look at converting it into base 9, the powers are 1, 9 and 81. 81 divides 124 once. 124 minus 81, we are left with 43. 9 divides 43 4 times. 9 fours are 36. 36 43 minus 36 is 7. 147. This is 147 in base 9. Find the sum of x and y. As we can see, this is x, this is y. x plus y will be 11. Option C becomes the answer. In terms of level of difficulty, I'd say moderate level of difficulty, because first of all, you have to find the number and then convert it. Because 8 and 9s are involved and the number is small, the calculation is not very high, and therefore about 2 minutes should be good enough to answer the question. N is a two-digit number such that the number formed by reversing the digits of n is 18 less than 10 if the unit digits is 5. So if the number is xy, and so that the number formed by reversing the digits yx is 18 less than n. So the number is 18 more than the number formed by reversing the digits, and therefore the difference between the two numbers would be 18. If the number is xy to start with, the value will be 10x plus y. The number formed when reversing the digits will be 10y plus x, and the difference has to be 18. 10x minus x is 9x, y minus 10y is 9y, divided by 9, x minus y is 2. It is given that the unit digit is 5. So if y is 5, x is equal to 2 plus y, or 2 plus 5, which is 7. Find its tens digit. The answer is 75. Reverse the digits, it becomes 57, 18 less than n. This I'd say is an easy question. If you've done basics of decimal, you would have come across this question. Not more than a minute or a minute and a half to solve the question. The absolute difference between a three-digit natural number and the number obtained by reversing the digits is 594. So how many such numbers are possible? Suppose the digits are ABC. The number is ABC. We are saying 100A plus 10B plus C minus reversing the digits gives me 100C plus 10B plus A. Reversing it will become CBA. The difference is 594. 594. 100A minus A is 99A. 10B, 10B cancel. Plus C minus 100C is minus 99C. 594. Divided by 99, A minus C is 99 into 6. 454. 594. A minus C is 6. Now, since it is an absolute difference, we could have both cases when A is larger or B is larger. So if A is basically the mod of this is 6. So if A is 1, C could be 7. If A is 2, C could be 8. 3, C could be 9. 4, we cannot have any value of C, because C will either be minus 2 or which is not possible, or 10. Similarly with 5 there is a problem. If A is 6, if A is 0, if A is 6, C could be 0. If A is 7, C could be 1, A is 8, C could be 2, A is 9, C could be 3. So 1, 2, 3, 4, 5, 6, 7. We get 7 cases where the absolute difference could be 6. I am not taking the case where A is 0 and C is 6, because ABC is a 3-digit number, so A cannot be 0. On reversing, we might not get a 3-digit number at all. For example, we could have 610. On reversing, we get 016, and 610 minus 016 will give us 594. So there are 7 cases, and for each of these 7 cases, we could take any one of the 10 values from 0 to 9. So 7 cases for A and C, and for each case, B has 10 values. So the overall number of possibilities is 7 into 10. So 70 numbers are possible. Moderate level of difficulty, because it also uses a concept from PNC, that is counting the number of cases. Apart from that, should not be very difficult in solving. I'd say 90 seconds should be good enough to answer the question. Find the last two digits of 79 raised to power 64. 79 raised to power 64. What we have to convert it into a number ending in 1. So we take the square of 79, and therefore the power left outside is 32. Now we try to find out the last two digits of 79 square. 79 into 79. 79 into 79 will end in 981, 1, 8, 9, 7 are 56, 8, 64, 7 9s are 9 7s are 63, 8, 71. 7 9s are 63, this will end in 41. The last two digits of this will be the same as last two digits of 41 raised to power 32. And for a number ending in 1, all we have to do is multiply the tens digit of the base in units digit of the power. 4 twos are 8. 81 will be the last digits of this number. Hence, 81 will be the last digits of this number as well. Again, the process remains standard. Since the last digit is 9, we also don't have to calculate the fourth power. Only the second power is good enough. Hence, about 2 minutes to answer the question. Moderate level of difficulty. If x and y are positive integers, then the last digit of which of the following is same as the last digit of x plus y? Because the last digit has a cyclicity of 4, we can say that the last digit of x will be same for numbers which are of the form 4k plus 1. That is x raised to power 1, x raised to power 5, x raised to power 9, x raised to power 13, and so on will have the same digits. Similarly, y will have the same digits for 4 raised to power k1 plus 1. So 5 y raised to power 1 plus y raised to power 5 plus y raised to power 9 plus y raised to power 13 will have the same digits. From options, we can say x raised to power 13 plus y raised to power 13 will be the same as x plus y, hence the same digits. Option B becomes the answer. Level of difficulty wise, that's an easy question, not basic single digit cyclicity. 90 seconds to get the answer correct. The pages of a book are numbered from 1 to n, where n is a natural number. The total number of times the digit 3 is used while printing all the page numbers is 184. What is the value of n? Now, when we write any 100 natural numbers, the digit 3 in tens and ones place will occur 20 times. So when we write page numbers from 1 to 100, we have 20 threes in tens and ones place. Similarly, from 101 to 200, we have 20 threes in tens and ones place. From 201 to 300, we have 20 threes in tens and ones place. From 301 to 400, I'm trying to get as close to 80 as possible. We have 20 threes in tens and ones place. Also, from 300 to 399, we have 100 threes in the hundreds place. So if when we write numbers from 1 to 400, the number of threes that we'll have is 100 plus 20, 20, 20, 180. 1 to 400 has 180 threes. We need 184 threes. The pages of a book are numbered from 1 to 8, where there is a naturally total number of times the digit 3 is used while printing all the pages is 184. What is the value of n? Now we need 4 more threes. So the next 3 we will get at 403. After that we'll have 413. After that we'll have 423. Then the series for 430 will start. This is 1, 2, 3 and then 4. At this point we have 184 threes. Beyond this, if we write 431, another 3 will be required, and therefore this will not be the case. Hence, the last number that will be written is 430, and that will be the value of n. Again, counting numbers is the basic concept here. Because 184 is a number that is not between 300 and 400. If the number was lying between here, the calculation becomes a little difficult, because then we'll have to count the 100 place 3s separately. But since it is beyond 400, I'm saying should not be very difficult to solve. 2 minutes should be good enough to answer the question. Find the last digits of 32 raised to power 222. 32 is a pure power of 2. Can be written as 2 raised to power 5 raised to power 222. This will be nothing but 2 raised to power 5 to the 10. 0, 1, 11, 1, 1110. This is nothing but 2 raised to power 10 into 111, which is nothing but 2 raised to power 10 into odd. Now the thing with 2 is 2 raised to power 10 into odd ends in 24, whereas 2 raised to power 10 into even ends in 76, because 24, 2 raised to power 10 is 1024, 24 into 24 is 76, 76 into 24 is 24, and so on. This is 2 raised to power 10 into odd, so this will end in 24. Option C becomes the answer. Again, since this is the case for 2, I'm saying not a difficult question. if you've done this topic, should be an easy question to solve within maybe 1.5 minutes. If you look at the overall level of difficulty for this test, moderate level of difficulty, 6 to 7 questions for a 97 percentile, 18 to 21 minutes to go through the entire test, as I said earlier. Which are the questions I would choose? I would go with 2, 3, 5, 6, 7, 8, 10. Which are these? I would not attempt this question in the exam, most probably, because again, when you're counting cases, it is very easy to drop a case here and there. Definitely doing this simple question. Would have done this as well, probably, because the numbers are not very difficult. This question is something that you can take a call on, because uh, once you get 124 to start with, then it becomes easy. Otherwise, it could be difficult. In any case, 3 and 4, you could choose one of these questions to attempt. This was one of the easiest questions in this test, should have been done. This, I think, again, was not very difficult. Absolute difference counting cases. Standard process, therefore, should be attempted. Basic questions, single digit cyclicity should be attempted. This, I think, is a question that might be a bit tricky, especially understanding that that 184 is a number which is easily breakable is something that might be a little bit challenging. So maybe left. Standard process should be attempted. So my attempt for this paper will be 2, 3, 5, 6, 7, 8, 10. 3 and 4, you can take a call into which one you want to attempt, but definitely 6 to 7 questions in this paper.